a few interesting topics uh, in pandas, how you can read data, how you can manipulate the data, how you can process the data. So this next part, we will continue with some basics with machine learning basics. Now we read our data into a pandas data frame. Now what we will do is we will apply what we have learned in the class in terms of regression. We will apply linear regression first. To apply linear regression, if you remember, we have included some code and we are using sklearn for regression. And from sklearn, we are calling linear models. And we would like to import linear regression. So this is our linear regression. We also would like to start with splitting our data. So to split your data for train and testing pieces or percentages, also you can use sklearn. And from sklearn, you can use model selection, import train, test selection. And I would like also to use metrics. From metrics, I will be using mean squared error. We covered mean squared error. I would like to use R squared. And let's use also maybe mean absolute error. So these are three metrics we use. And now I just ran this cell to make sure everything is installed. If it's not installed, you can just go with exclamation mark like this, pip install sklearn. sklearn is one of the biggest or most widely used package for machine learning. So now if you run this one, it will make sure sklearn installed for you. Okay, so we'll use the same data set that we have in the data frame, the patient's data set. It includes 30, I think 53 different columns, and it does have 500 rows. Now, what we will do is let's try to predict, for example, the systolic blood pressure. And I'll be providing the age, and my model will be trying to predict what would be uh, the systolic blood pressure. So I will filter the data. So I do have the data. I'll just save the data. I'll get the data frame. And then from the data frame, I'll be saving two columns. The columns will be age. I think it's age in years. The second one, I will be saving the systolic. I think it's systolic blood pressure. Okay, we are all good. So we save the data. Now, this will keep only the data that we need. So keep the data we need for this example. Now, the next piece, it will be about identifying what are the features that I will use. It will be one feature or features, and the label, which is, I refer to it as the target. Okay, so we will create the data into the age group, and Y lowercase will be the target. So this is my data, the age, and Y will be the target that I'm looking for. Let's split the data for training and testing. Now, to split the data for training and testing, we will use the function that we imported in here. It's called train test split. Now, what I will do is I need train and test. So I'll go with X underscore train, which is the data itself, X test, Y train, Y test. So this will be the label for training, and this will be the label for testing. It will call the train test function. It will accept the X and Y, which are the labels. And how much is your test size? I wanted to create 80% for testing, for training, and 20% for testing. So I'll say the test size is 0.2 or 20%, and that's it. Now, there is a variable in here that I like all the time to declare. It's called random statistics. So you set this one, so every time you run your algorithm, it will give you the same results. If you do not use it, every time you run your algorithm, you will have a small modification, very slight modification. Now, we have declared, so this will split the data into 20% testing, and 80% for train. Okay, so I do have the testing and training splits. I'm good now. I declared my model. You can call it whatever you want. I call this model equals linear regression, which is the same linear regression that we brought up from here. Now, after that, I will fit. Now, this is the training of the model. Model.fit, that means take the training data set on this linear regression, fit it with the labels, and create the model. Now, to test your model, you need to create the prediction. So what model, which is this model, after this is, okay, this is deciding the model to use, which in our case is a linear regression. This one will be train the model on the trained data. Now, this one is evaluating, or you can call it predicting or inferencing. All of them, they have the same meaning. Evaluating, predicting, inferencing the test data set on the model trained before. So far, I have not done anything. I'm just writing the code, and we wanted to see what the prediction will become. Run. Now it ran, it trained the model. I can go and look at the results, Y prediction. Now these are the prediction results that we have based on the test data set. Now I wanted to see how far we are from the model itself. Remember that we could see from the model, we said you can see the coefficients. So I can go and look at the coefficients of the model, just to see what are the coefficients of this model. So I do have the coefficient is this coefficient. It's a numpy, and this is the number of the coefficient. I also can see the intercept of the model. So you can, so let's just print. So these are the parameters that the model have learned. And this is a coefficient. This is the coefficient. Let's print the intercept. Now you can see this is the coefficient and this is the intercept of my model. I also can look at the mean square error. We said mean squared error. We already called the function, and the function, it was, I think, mean squared error. And the mean squared error, it will compare the test with the prediction. So it's the Y prediction that we have created in here, and we will compare it with the test. So it will be Y test versus Y prediction. We can do the mean absolute error as well. Now you can see the error is very high, it's 300, and the mean absolute error is 14. We are still looking at a very high error. We can also look at the R square, and the R square is also, I think, is fairly high. Now what happened is we trained our model. The data is fairly small, so the data is not that huge, and you can see that we are trying to predict the blood pressure based on the age, which might not be accurate because I mean the age doesn't have it does have an association, but that might not be true. So let's just look at the results. My results, I'll create a data frame, pandas data frame. So results equals PD data frame. What the goal in here, I wanted to compare the actuals. So these are the actual values. And remember last time how we created a data frame. Y test versus predicted. And let's just look at the top 10. PD data frame, this is actual, this is predicted, and okay, I am missing something in here. So this is data frame, so it needs to be in the form of a dictionary. Okay, now we can see mostly my model is over, like it's just producing random values. But the idea is we do have a linear regression. This is the training and testing. Our test is very small, and we are looking at the age. And from a clinical perspective, you might know that this might be inaccurate because you cannot predict the blood pressure from the age. So let's look at a little bit more information. Let's look at how can we predict, like for example, the age. Maybe we can predict the let's say the HbA1c from the age. So instead of just looking at this, or it's not that from the age, I would like to use multiple variables as an input for my model. So in this example, what we will do, we will try to use linear regression, but within our linear regression, we will use multiple variables. If you remember, we have seen a regression and a multi-input, a multivariate regression. So the features that I'll be using, so let's look at the features. So it's the same story. I am importing from sklearn uh, pandas. We already have it. Train split. All of these measures, they are the same. I wanted to make sure that I install sklearn if it's not there. And we do have other things that we will be importing, but we will import them as we need them. So the features that I will be using, features, let's go with, for example, age year. And I will use the gender, so I'll use the sex. And also I'll be using BMI. I'll be using smoker status. I think we have you in here. I'll be using also uh, maybe medication adherence. I do not want to get into the primary diagnostics. I will not use medication. 1 or 2. I will use what else we have. Mm, let's use refill count last. Refill, I think it was refill count last 12 months. Let's use also disease and duration for the last 12 months. Let's use systolic too. And let's use, okay, so I think this is enough. I will exclude this one because this will be our target. Now my target equals this one. Now data frame, let me just print the features and see all of them are numbers. I'm missing a double quotation in here. Data frame of features. I might have a typo somewhere. Yeah, disease duration. Let's just remove disease duration for now. Age year. It was age years and years. Okay, so I do have everything. Let's look at, okay, some of these variables, they might need like a special treatment. So we have to treat them differently. Year, okay, this is a number. Sex is male and female. We can use it 0 and 1. BMI is number. Smoker status is never, former, current. Medication adherence is high, low. Refill count, systolic. Okay, so all of them are good except sex, is smoker status, and medication adherence. So we'll try to handle these ones. Okay, now as you see in here, we selected set of features. Let me just remove some of the spaces, extra spaces in here. We have the target and we have the data frame. Now, I would like to get the full data. So this will be the data that we will train our model on. So we'll call it data equals. Now it will be the data, the features themselves, plus the target. Now, if I add the target in here, remember we have the target. So I wanted to combine them, concatenate them as a list. Now let's just go and see what's the impact of this. Remember, what's features? Features is a list. Let me just show it to you in here. So it's a array. I wanted to append target to it so I can have target as well. So I have, this is the target. So I have all of them together. And what I would like to do is I would like to get the full data frame of this data. So now the data, so what did I declare target as? It's a string. Now what I'm trying to do is data frame, target features. So this is the list of features. Did I call it feature or features? Okay, they are features. And so this one is not an index of the data frame. So why it was treated as, oh, sorry. So this is the reason I have a comma in here. Now I come, okay, so you can see in here, we concatenated all the data. Now, if you look at this one, now the features will include the HbA1c percent, and HbA1 percent was not included in here. Now I will go and create the data. The data will be features plus target. Okay, so now data is correct. Let me delete this one. Now we created the target and we created the data. So we do have numeric features. Let's just declare the numeric features. Let me just save numeric features in here. Numeric features. So age in years, BMI, sex is not. Let's just delete it. Smoker status is not. Medication adherence is not. Refill count, it was. Disease duration, systolic. Okay, so I think all of this is numeric values. So let's just print them to make sure all of them are numeric values. Okay, perfect. So all of them are numeric values, just to make sure that they are numeric values so I can go with them. So the categorical variables are the other ones. So I'm not going to look at them. What I will do is I will look at the ones that I have right now, and let's try to create our data in here. So this is data 2, and I'm looking at numeric features, and I'm looking at the target, and this should be my data 2. So this is data 2. I also wanted to create my X and Y. So our X is, so this one I do not need it anymore. So X will be the data. So it will be df of numeric features. And small y will be the labels, which will be the df of target. Okay. Now I wanted to split the data. But remember how we split the data? We just say X train and Y train, and then split, and we split the data 20%, and we will go with random state equals 42, for example. We declare like a model. Our model will be a regression. We will feed the data, we will fit the model, and let me just copy the same things that I created before. So we train the data, we predict the test data. I think we call it test as well. And let's run our model. So it says Y contains NaN. So there are some missing values. to fill these missing values, we can use impute. So there is something called impute. Impute is filling the missing values. So we do have something called imputer, simple imputer. But I do not want to get you into this. So what I will do is I will just go to the data frame. I'll create a copy of this data frame. I'll call data frame 2 equals data frame 1 dot copy. So this will copy the content of data frame 1 and create a copy of it. It's called the df2. And df2, I will apply drop NA. Remember that drop NA, it was dropping the values that doesn't have, or the values that has NA in it. And I do not want to create a new data frame. So I told just create or drop the NA and keep it in the same place. I'll just go in here. I will create, where are we at? Okay, I created a copy of the data. I call this one as df2, and this will be df2. And wherever I'm using df, I will just use df2. Did I call it df2? Okay. Now split the data on X and Y. I trained the data. Now hopefully the data will be trained. Okay, everything is good. And this is the prediction of my model. Now we created the prediction. Let's look at our model now. And let's remember that our error was, we'll come back to the errors in a second. I run everything and you can see that I do have more coefficient now. The intercept is different and the error is different. Let's just go and copy this and paste them in here so we can compare. So in this case, we use the age in this results, the green results, we use just the age. Whereas the results below, we used more variables. Now remember, we used age, so the coefficient was 1, just the age. In this model, where we used age, BMI, the refill count, 3, 4, 5, 6, and 7. So you use 7 different features. Now I have 1, 2, 3, 4, 5, 6, 7. So these are the 7 features. Intercept is the same. And I do have now mean squared error, mean absolute error, and R squared. Let's look at the mean squared error. In the first case, when I just used the age, it was 300. Our goal is to reduce the error. So now 300 compared to 2.9, almost 3, is a huge difference. Mean absolute error is 14, whereas in here it's 1.3. Now you can see the model has been enhanced and the enhancement says major. By just using multiple, so we have done in here, we use just multiple regressors. We did not use just a single regressor. We used multiple regressors. So our input was multiple regression or multiple regressors. Okay. Any questions so far? Okay, if no questions, let's try from the linear models. What I will do, I will repeat everything. And instead of just calling linear regression, I will call reg. Remember that we have seen reg as one of the models that we have. So reg is one of the regularization that we can use for creating forecast or prediction. So I use reg and I do have the same features. I have the target, the same target, and my model in here, instead of using linear regression, what did I do? I would just use the reg. Reg regression. Let's go with the same hyperparameters and not hyperparameters, sorry, the same things that we printed before. And let's see the results. Now the results for reg. So I'm using reg, I'm fitting the data. Now let me just copy the results that I've seen in here. This is the this is the linear regression, the simple linear regression. So the intercept was 8.9. This is very similar in here. Coefficient is, they are There is one coefficient. What are we using in here? Let me just verify. So I do have a list of features. We said we are not using this list. That's fine. DF2 data, numerical data, data 2, DF2, numerical features of the target. The model is rich, and oh, sorry. And here I'm just retrieving the first one. I wanted to show all of them. Okay. Yeah. So these are the results. These are the coefficients. It's the same story. We do have multiple coefficients, and we can see in here we do have the I think the results are similar. Yeah, they are very similar, except that for instance, the mean squared error is 2. Yeah, it's very similar. The mean absolute error, the R squared is very similar to the previous one. Now we used Ridge, and for this example, for instance, the results are very, very similar to what we have seen there. Let's use a different one. Remember that we have talked about lasso. Any questions? Okay, so what I will do instead of Ridge, I will just use lasso. Okay, so we have Ridge and lasso. And our model is now lasso. I will fit the model. For this data, I do not know how many data points we left with. And let's go with, sorry, I wanted to copy this one. So we trained our model, and let's look at the results. So it seems that Ridge and regression are much better than lasso for this case. Okay. So this one I need to make it as a comment. Let's run it. And what we have the mean square error is 2.8 in the lasso, whereas it was 2.9. So it's much better. So the lasso in here, it was much better than the ridge and the linear regression. And you can create a quick comparison to compare them together. Let me see what else. Any questions so far? Any questions so far? So there is one other model that we can use. I think we talked about it quickly last time. It's called the random forest. So what I can do is this will be, it's not from linear models. So it will be from sklearn. Now it's not model selection. It's from ensemble. We have random forest, the random forest regression. Remember that we are applying regression in here. So I have random forest regression. So I'll just apply the same thing. And instead of lasso, I'll go the random forest regression. And it tells me a column vector y was passed when one dimension array was expected. Please change this of y. I think the function for evaluation is a little bit different for this regression. Okay, so random forest regressor. I provided list of features. I created the model for regressor and fit method. Let me see, did it run or it's just warning? Let me just get the same things that I've done in here. Okay, object has no coefficients. Okay, we understand this one. It's not 10. It's not a regression. Okay, so it was able to run, but I do not know why it was giving us this error. Okay, says that column. So it might be this one, values, even though I'm positive that should work. It's a numpy. So one idea, I can just copy it and take it to the internet, try to find out what's the exact error. So this random forest, I need to specify a few parameters in here, but most likely it should work. It does have default values. Okay, all of what I can do is I can pass it to Google and find out what would be the error. Okay, let me just make sure what's my training. Okay, I think it doesn't accept. Okay, it seems this solves the problem. Okay, so it runs now. The problem is it doesn't take a pandas data frame as a label. It has to be a list. But let's see how different the results were in here. So you can see the random forest is not providing us with better results. So the random forest is providing us with and mean squared error is 1.15, mean absolute error is higher, and R square is higher. I can play with it. So there are hyperparameters in random forest. For example, you can provide, I think, an estimator and underscore estimator. I mean, the more that you increase it, the more overfitting that you might run into. I can just put it 1000, but this will get me overfitting. It's capped out. Let's say 25. Okay. So there are some hyperparameters that you can play with for the random forest. And there are other methods that you can go with, such as, so you have seen regression. I mean, I'm not going to get into logistic regression for today. So inshallah, next time what we will do is we will get back out to our normal slides. We'll talk about the theory, the methods and theory, and then we'll come back and apply them in Python. Any questions so far? Any questions so far?